All right, class, now we're studying our fourth section, finding zeros of polynomial functions. We've now been able to use our skills of division to find all the zeros of polynomial functions. But up to this point, we've always been given one of them to help get us started. Now, we're not going to be given those things. There are a couple theorems and properties that will help us get ourselves started and find one of the factors. The first theorem you need to be aware of is the remainder theorem. It states that if a polynomial is divided by x minus k, so notice it's a linear function, the remainder will always be the function value of k. It's basically saying that if you plug in whatever this k is, it will tell you what the remainder is. For example, what is the remainder of 4x squared minus 10x minus 21 divided by x minus 5? I could go through and do synthetic division to figure out the remainder, but since it only asks for the remainder, all I have to do is plug in the opposite of k, and that will tell me the remainder of the function. 4 times 5 squared minus 10 times 5 minus 21. 5 squared is 25 times 4 is 100 minus 50 minus 21. 50 minus 21 is 29. So the remainder is 29, and technically, remember, we expressed that as 29 over x minus 5. The factor theorem states that if a polynomial f of x has a factor of x minus k, it has the factor of x minus k if and only if f of k is 0. Meaning that if I plug in the number and I don't get a remainder, then I automatically am a factor, which follows the rules of division. So let's do an example involving that. Is x minus 2 a factor of 2x to the 4th plus 7x to the 3rd minus 4x squared minus 27x minus 18? And again, I could go through and do longer synthetic division to figure out if it's truly a factor, but it's not the most efficient use of my time. I'm going to plug in the opposite of k, so I'm going to plug in 2 in for x. If I get 0, then I know I have a factor. So 2 times 2 to the 4th plus 7 times 2 to the 3rd minus 4 times 2 squared minus 27 times 2 minus 18. So 2 to the 4th is 16 times 2 is 32, plus 2 to the 3rd is 8 times 7 is 56, minus 2 squared times 4, which is 16, minus 27 times 2, which is 54, minus 18. So now I'll just combine these. 32 plus 56 minus 16 minus 54 minus 18 is 0, which means that x minus 2 is a factor. And this leads us to our next step, the rational zeros test, also known as the rational root theorem. It states that at least one of the zeros of the function can be expressed by taking a factor of the constant term. So, for example, 3x squared plus 2x plus 7. So if there is a 0, then that 0 will come from, or can be represented by, one of the factors of the constant term divided by one of the factors of the leading coefficient. Which seems a bit strange, but here's how we apply it. Find all the zeros of 2x to the third plus 3x squared minus 8x plus 3. I could try to factor this by grouping, but I don't think this actually works if I try to factor it by grouping. So I have to try to use polynomial division in some way, shape, or form. But I don't know any of the zeros. Well, the possible zeros. Not saying that every single one of these will be a 0, but all of the possible zeros can come from taking the factors of the constant term. So numbers that multiply to give me 3 would be 3 and 1, and dividing those by the factors of the leading coefficient. So numbers that multiply to give you 2 would be 2 and 1. So the possible zeros would be 3 over 2, or 3 over 1, which is just 3, or 1/2, or 1 over 1, which is 1. From this point, I can use my remainder theorem to figure out which one of these are actually zeros. Once I find one, then I can do synthetic division. It's a lot better than trying to guess and check until I find something that works. If I were you, I would pick the whole numbers. Let's try to plug in 1. So 2 times 1 to the third plus 3 times 1 squared minus 8 times 1 plus 3. So 2 plus 3 minus 8 plus 3 is 0. So that means that 1 has to represent a factor. Or 1 has to represent a solution, which means that the factor would have to be the opposite of that, x minus 1. Now that I know one factor, I can do synthetic division and figure out the rest. So 1's going to go in my box, and then 2, 3, negative 8, and 3. Drop the 2 down. 2 times 1 is 2. 3 plus 2 is 5. 5 times 1 is 5. Negative 8 plus 5 is negative 3. Negative 3 times 1 is 3. Negative 3 and 0. So right now, I'm factored to be x minus 1 times 2x squared plus 5x minus 3. And I can try to factor this part further. Factors of negative 6 that add up to give me positive 5 would be positive 6 and negative 1. I can split up the middle term. And factor out a 2x. Factor out a negative 1. And now I'm completely factored. So I want to find all of the rational zeros. X equals 1, x equals 1/2, and x equals negative 3. And those would be my solutions. If you have any questions about this, please write them down and we'll cover them more in class.